Hello again and welcome to ISAC Software Academy Linux course. In this lesson we will be covering basic script development, and in so doing also the bash shell or born again shell that is most commonly used in Linux. There are other shells available, but due to the sheer popularity of the bash shell we will be utilizing that for this lesson. Others that you might be interested in looking into would be the C shell, which is very similar to the syntax used by the C programming language, and the Korn shell. Something to keep in mind is that the shell scripts in Linux are similar to but are more powerful than the DOS batch files or .bat files of which you may be familiar. There are more possibilities in the Linux shell than there is in the DOS shell, and as such that means that as a result the shell's scripting is more powerful. Now, a script is simply a list of commands in a plain text file. And this is a somewhat simplistic explanation, but we can expand upon that shortly. Now, these commands can be used to do practically anything that you want in the shell manually that you can put into an automated fashion. And that's the entire purpose of a script, is to make it an automated thing. Rather than type in 20, 30, even up to 50 commands or more manually, you can actually make it a script. So if it's a common thing that you regularly have to actually do, you can do it all in one giant script and thus save yourself a great deal of time. And obviously, being that it is a script, it is capable of programming features such as loops and conditionals. It is very similar to a C, C++ or Java level of control and power, and as a result it can be used for almost any purpose. Now, today we will only be covering the basics. There are more advanced features available. However, they are out of the scope of this material, and as such we can't really cover them in the time allotted. The basics, however, are enough to do some quite advanced and rather tricky things that you can program yourself to almost think for itself in a way with what we'll be covering in this lesson. Now, this is a list of what will be covered. We're going to first cover how to run a script, which is has been covered briefly, but we'll cover a couple of other ways that can be done. There is also creating the script itself, so before you even enter anything in, how to actually make that file, and also how to use variables, which for those who aren't familiar with any programming terms, a variable is exactly what it sounds like. It is something that is variable. It is a placeholder for data, and it is where you put values that you want to store, at least temporarily. Those can be written out to more permanent storage than a variable, but generally they are for temporary storage, and it usually references something in the memory, in the system's RAM. And we'll also be covering user input, which is obviously typing on the keyboard, and flow control, which in this instance is going to be ifs and fors and while loops, as well as some switch statements basics as well. Now let's cover some practical attributes here. Now, as you can see, I have put in a test1.sh, which is obviously short for shell. Now I've also given this execute permissions. Now we will be covering this shortly as to how to do this for your own. However, for the moment, just be known that all you need to do to run this is put in the /test1.sh and it will actually try to execute it. It's presently empty, so it won't do anything, but there is that. The other option is that you can also do a dot and a space as you're already in that directory, and there is also the option of doing sh for shell, and then also those options. So sh for shell, bash for born again shell, dot meaning execute this now in the current directory, and dot / meaning effectively the same thing. So that's how you can run your scripts when you actually create them. Now, to actually create a file, you can use the touch command. Now, we've actually spoken of this previously, but I'll cover this again just for this purpose. And we're going to create another file called test2.sh, and that's now been created, as you can see there. Now you can see, however, that there are no execute permissions for anybody here. Now, to make it quick easy just to get it to execute, what I can do is do the chmod command that we've done previously with a +x, meaning add execute permissions, to test2.sh. When we hit enter, we can list out the contents, and you can see that it is now executable for everybody. And that means that you can actually now use that as an executable shell script. If we remove the execute permissions from test1 just for the moment and try to actually run test1, it actually states that the permission is denied. Now this is because it does not actually have the execute permission. Now you can actually create these files easily by going to a graphical interface like this. However, as I'll show you, when you actually go to create the new document, and we'll call this one test3.sh to be original, when you go to change the properties, you'll note here there is no way to actually change them as executing as a file as a program here, but you need to note that that is there. That is the exact one you want for it to execute. Once you've ticked that, you can click close, and you'll see by listing these permissions, oops, sorry, there we go, that test3 is executable once more. So at this point we may as well make use of one of the ones that we've already done here. I'll actually make test1.sh executable again. Now I'm going to use the nano editor for this. I would suggest you do the same, but it is not necessary. You can use any text editor. You can even use a graphical one if you like. However, there are many situations where you would prefer to use a command line based editor, quite simply out of necessity in some instances, to get this done. So now that we're in here, you'll note that there is a hash that I've just typed in there. Now that hash indicates that anything following this hash is a comment. So I can actually write whatever I like here, which I'm actually going to use this particular section here to name our file. It's going to be our test1.sh, and it's going to be utilizing the bash, which is /bin/bash if memory serves. However, I believe I'll actually not really need that. Now at this point everything that is covered here is in fact a comment and not actually executed by the system. Now if you want to execute something, you can use the echo command, which is one of the ones that will work, and put in any text you like. For example, hi there. Now when we actually save this, we can go out and run this, and it will actually print out hi there for us right there. So as fun as that is, we might also want to say a name. So let's use some correct capitalization and get this all proper, and we can do this. Now $1 is a variable, and this variable is used to specify the first parameter given to, well, in this case, a script. So when we do this, we'll type in ISAC, and it now spits out hi there ISAC. And you can continue to expand upon this as much as you like. There are many other things here, and there's also the $0 sign will actually, I'll just demonstrate that one, and we won't bother with all of this here, but you'll note when we do this that it's actually the command used to execute it. Now if we changed this to test1.sh again, it's actually being executed by bash. So it's actually the first actual parameter, which is the script or executing file itself. The first parameter passed to that is $1, and the second one is $2, and so on and so forth. Now we can actually do something a little bit more complicated, in that we can start with an if statement, and we will say if $1 actually what I'll do is introduce another variable, which is the $? Variable. Now this variable will actually provide the number of arguments, so we can actually do that with a not equal to 0, and it will run whatever we put in this section here, which we want to run echo hi there, I will do lowercase hi there, and $1. Now this is where you would end the if by doing phi. And when we do this, we'll obviously exit and save. And now what we'll do is execute this with no extra arguments. And as you can see, if it doesn't work properly, this is what you'll get. I've obviously made a mistake, so bear with me. So we'll give our first lesson on debugging as well, which is effectively just finding out where the problem is. Okay, now I've just realized I've actually done a question mark rather than a hash, which is what I was actually wanting to do, and yep, I forgot to do then. So now we've got, I'll put that back up again so you can see it. Everything's the same except I changed that there to a hash. It was a question mark, and I added then after this statement. Now it doesn't have to be there, it can in fact be up here, you can put it there. A lot of people prefer that because it looks a lot more neater, and this is actually something that you kind of have to get used to with scripting if you're used to programming in some other language. For a start, it's an if statement and it has a then statement so that it does whatever's after that there, and it ends the if statement by saying fi, which is obviously if backwards. This is also true in some other instances which we'll be into later. So now that we've done that, we will save it again and we'll run it. And first off, we'll run it without... it still has a problem. Well, let's try again. May in fact not like it being up there, but it should not have a problem with that. So we'll try that again. Okay, now we're happy. So it runs, doesn't display anything. That's because we've said if there's nothing there, so if there is something there as an argument, then say hi. Otherwise it does nothing. So if we put in ISAC again, it now says hi there, ISAC. So this works exactly how we want it to. So we go in and we'll change this somewhat. It's now going to be if, then, and then we're going to do what's known as an else clause. Now at this point we're going to do another echo statement, and we're going to say hi there. I'll keep it the same actually, make that a T. Hi there, stranger. And we'll save that. Now what this should do is, if we do it without any parameters, it should give us hi there, stranger. As you can see, it's done so. And this time around we'll do it again, and this time we'll just simply say test, and it should say hi there, test, as it does. Now just show you what's going on here, which is it's going if the number of arguments is not equal to 0, then echo the first argument. Otherwise, or else, echo hi there, stranger, because the name hasn't been supplied, so that would be appropriate. And then end the if statement. Now there's a lot more complicated things you can do with this. Obviously you don't need to use a not equal then. You could in fact specify that you wanted to make sure it was the $1 sign, but for our purposes that works. Now we can actually do, what we'll do is we'll keep that if statement, but we'll now introduce a for statement. And in this statement we're going to use a different syntax to the if. Now I'm actually going to introduce a few concepts in this for loop. For a start, we're actually going to use a for I in, and now this is where it's going to be something different. This is called a backtick. Now you'll find this right next to the tilde, and a tilde looks like that. You can see the little wavy line. This is usually above the tab key to the left of the 1 key, and you want to use that one specifically because that means execute between these two. So I'm going to use 2 of those and write inside it, and I want seq, meaning sequence, and I want it to be between 1 and 5. Now in this instance I want to change this to actually be the $I sign. Now when we do this, we actually want to have at the end of our for loop, it always says done, and it should say do. So we'll now save and Now we will execute that, and it should loop through and tell us hi several times, so long as we have something else like moo, why not. Okay, I've also forgotten to do one tiny little thing which I was actually just telling you about. It does not have the backtick, so what we're actually going to do is just leave it as $1 because that will prove the point. So it will actually list out now. Oh, okay. So obviously we need to debug again. Thinking it probably wants backticks here. We'll probably want to do the backticks in the right place, which would be with the eye over here, and then there we go. And this should solve the problem. It shouldn't have any issues with white space, so that's something to keep in mind. It may, however, have an issue with the line here. I'm not sure why it would, but it might. So we'll just do that and see if it works again. Otherwise, might have to go back to the drawing board. Yep, so I've actually got a bit more debugging on my hands. Okay, so as it turns out, my issue was this right here, and then because I changed the backticks here, it actually failed to work. It will now actually function. It will not print out what I say, but it will, so long as there is something there, actually print out what we want. So here it goes, and you can see hi number 1, 2, 3, 4, and 5. Now, obviously, we want to actually add to this a little bit, so we will be going back in. Now you'll actually note here that I've used a for loop when we could have used a while loop as well. For the most part, the for loop will do whatever you need it to, so we're not going to cover the while loop either today. This will pretty much allow you to do everything you could possibly need to do, and as such is the end of this lesson. I hope you've enjoyed it, and thank you for your time.